Tara is someone who I was first introduced to through her work with Beaker, and it's safe to say that you do all the interface for Beaker. I mean, it's collaborative, but you're like the interface person at Beaker, which is quite a challenge when you think about how familiar people are with, you know, the vernacular of a browser, like in their expectations of what a browser looks like and what it's capable of doing. And when you start to extend the possibility within a browser, like the forking is a really good example of like that's a really challenging thing to figure out how to make it accessible to people with like a range of understanding. And so when I first downloaded Beaker, I was really impressed with how things like how it was communicated that, you know, sites are a collection of files, and how there's a certain malleability to the files, and you can get in there and you can work with it same as you would any file that's on your machine, which is a critical difference between like you know, more of a platform way of thinking. And this is maybe like extending your question a bit about the difference between what we call a site and what is a platform. And I think a big part of that is like the data ownership side of that, right? Like when you publish something to the web right now, oftentimes you're publishing to, you're handing over the data to a company, right? And they can do with that data, they have a pretty wide sort of like range of application with what they can do with that, right? And it's kind of abstracted away again through like good design, right? Like you're just clicking the button, you're not thinking about what's happening after that. And so to design a tool which is trying to communicate what's happening through the interface is like a pretty ridiculous challenge. And so that's when I think of Tara, that's what I think about is really good interface design. And so yeah, so welcome Tara.
Well, hi everyone. Today I'm going to be giving an abbreviated history of the web, but I'm going to take a specific emphasis on one specific architectural choice and some of the lasting political and social consequences it's had. So like John and Kyle said, my name is Tara, and I'm one half of the Blue Link Labs team. We work on a few different things, like Hashbase, which John showed earlier, but our primary focus is a project called Beaker. Beaker is basically our opportunity to build the web that we think ought to exist. And we're doing that by being a bit opinionated and experimental instead of sticking to the regular web standards. And the primary experiment we're running with Beaker is by putting a peer-to-peer protocol into the browser. So just like you would browse HTTP websites, you can browse DAT websites. And because DAT is a peer-to-peer protocol, it unlocks some really cool things like being able to publish and create websites and host them directly from your computer. So that's what I work on. And while I do think Beaker is very cool, this talk is actually not about Beaker. Rather, I hope to provide a historical and technical justification for why something like Beaker ought to exist. So, in order to do that, I think it's pretty important for us all to have an understanding of what the web actually is right now and what it was intended to be when it was conceived of. So if you think of the web from the widest possible historical lens, you could say it's the apex of human communication. Just like the telegram or sending letters via carrier pigeon were probably the best way to get information from one person to another. But I want to jump ahead quite a bit, actually. I'm sure all the tens of thousands of years leading up to the invention of the web were interesting. But I want to jump ahead to the mid-60s, which was a time when it was pretty clear that computers were going to be an important part of human productivity. But there was still a lot of fundamental exploration being done in dozens of fields related to computing. And one of those fields was related to discussions about, okay, so we have this way to store information digitally and to retrieve it digitally. How does that change how we interface with information? And one of these ideas that came up was this concept of linking information. And in 1965, Ted Nelson was really interested in this idea, and he coined the term hypertext and also hypermedia, which is actually a pretty simple concept built on top of links. So a link is simply something that references a piece of digital information, but you can also use that reference to jump to the piece of data that it references. This example is actually a special kind of link called a bidirectional link, which means that B knows about the fact that A references it. And we'll talk more about this later. But also critical to the invention of the web was, of course, the infrastructure required to get pieces of data from one computer to another. And around the same time that hypertext was starting to be discussed, DARPA decided, we've got all this money for military research. It would be pretty cool to have a military network for getting messages across the country. So they reallocated $1 million that was supposed to be spent on military defense missiles and put it towards building a computer network. They didn't know what they were going to do with it or how it was going to work, but they thought it would be neat. And it took about 3 years to get design specifications together, but by 1969 there were 4 nodes set up at universities in the western United States, and they sent the first message with ARPANET. It was supposed to be the word login, but it was really just the first 2 letters before the whole system crashed, which is not surprising at all if you work with computers. And actually the first transmission was sent from UCLA, so that's a fun little fact. By 1975, ARPANET had grown dramatically. There were dozens of nodes on the coast and even a few in flyover country. And at this point, ARPANET was considered fully operational. And there were starting to be discussions about, hey, this thing is very useful. Maybe we should split this out into a civilian network and a military network. And eventually that did happen. Let's jump ahead to 1980, when there was a gentleman named Tim Berners-Lee working as a contractor at CERN. In the few months that he was there, he noticed that scientists and the technicians had a really hard time managing data and sharing data. So he put together a proposal for a method of documenting a system, and he called it Enquire. Enquire was a hypertext or a hypermedia project. It basically provided structure for linking pieces of information together inside of CERN and describing what kind of relationships there were. So includes and is part of, uses and is used by. And if you remember the bidirectional link that I showed before, Enquire used bidirectional links, and it worked really well for a closed system like CERN, where it's really beneficial to have your information system be very tightly managed and organized. So let's say you have a science group in CERN, they're managing some data, but another department wants to write a paper using that data. It's really it's a really good idea if you're going to use the data to tell those scientists, hey, I'm using this data, can you let me know if it moves or you change it? Works really well for that closed system, but also requires a lot of cooperation. Tim Berners-Lee eventually left after his contract was up, and I don't know if CERN actually used Enquire, but he put this proposal together, and it was pretty cool. He was obviously onto something, because in 1987, Apple released a project called HyperCard, which is basically a digital interface for note cards. And it was really cool because they had these semantic elements like buttons and arrows that you could use to compose your own note cards. And even cooler, they built a small scripting language on top of it called HyperTalk, which allowed you to add custom behavior to those semantic elements. And if you are familiar with the web platform, this might sound a bit familiar. Eventually, Tim Berners-Lee returned to CERN as a full-time fellow, and he spent a few years there and apparently felt like they were still struggling with organizing their information. So he yet again put together another proposal, which was quite similar to Enquire, but with one important difference this time. He wasn't using bidirectional links anymore. It was one-directional links. And this was actually a pretty controversial topic at the time. Hypertext and the concept of hypermedia had been around for decades at this point, and people thought that bidirectional links were going to be the best way to build a global information system, or just any information system. But this turned out to be a pretty important decision for him, because if you think about all the cooperation and collaboration that's required to do bidirectional links, it's just really not maintainable at scale. So being able to just do links to be able to make a link without having to tell the person or the person maintaining the data you're linking to was a pretty critical part of allowing the web to grow into what it's become. By 1990, Tim Berners-Lee had identified 3 pieces of technology that he thought would be required to build out this information system he imagined. And at this point, he was calling it the World Wide Web. The first part that he made, he specified, was hypertext markup language, or HTML, and it provided a shared language for how we can compose documents. He specified the Uniform Resource Identifier, which people sometimes call URLs, which created a standardized way of defining what a link is and how it should work. And lastly, he specified Hypertext Transport Protocol, which basically provided the way for a server and a computer to talk to each other and to get the actual documents to and from each other. And that same year, he put that all together and built the very first web browser, which he called worldwideweb.app. And this thing was really cool, because not only could you browse documents and define your own style sheets so that you could customize how your documents would be rendered, but it was an editor too. So you could take files on your computer, open them up in here, and actually edit the files. He eventually didn't have to spend as much time on this project, because in the first years of the 90s, there was an explosion of new web browsers. Lynx was a line mode browser that came around. There were a handful of others. And then in 1993, Mosaic was built by some folks at NCSA. So he, I think, just left this off to the side and let other folks take over. In 1993, something monumental happened for the web. CERN, by the grace of God, recognized that they had built something powerful, or that Tim Berners-Lee and his team had built something powerful. And they somehow understood that it would be way cooler if anyone could just use the code that they wrote and participate, and they released it all into the public domain. If this hadn't happened, I really don't think the web would be what it is today, so we're really lucky that this happened. Tim Berners-Lee was aware of the importance of the web being open pretty early on, but you can't have an open platform and just let it be. It still has to be maintained. It still has to have someone advocating for its health and advancement. And in 1994, he decided to create the World Wide Web Consortium, which is basically a group of people who write standards collaboratively to specify how the web, this thing, should actually work. And he is the leader of the W3C to this day. And what I think is the last major event that shaped what the web is, 1995, a gentleman named Eich created JavaScript. And this was super cool, because the web at this point was a tool set for getting documents around and sharing documents. But there was no way to endow interactivity to those documents, and JavaScript just opened up in all these opportunities for people to add customizable behaviors to the web, and totally shifted what the web's potential was. Okay, so now that we've looked at the web from this much smaller timescale, let's ask ourselves again, what is it exactly? I like to say that the web is a standardized set of tools for transmitting documents and interacting with documents. The web is not any one browser or any one piece of technology. It's just our shared agreement as humanity, the shared agreement we have about how we're going to get information from one person to another. But even more importantly than talking about what the web is, it's important to observe what values were encoded into the technology of the web. First of all, the web is open, meaning that anybody can participate as long as they are willing to use the shared language that we've decided on. It's decentralized, so there's no one node that's responsible for keeping the web up and functioning. And of course, it's shared. Sometimes that's great because it means we all get to decide how it should work, but it also means it's a little bit slow moving sometimes to advance. Nonetheless, these three things have been instrumental in making the web the weird, beautiful, strange, expansive landscape it is today. But I'd like to make the case to you that the web is fundamentally broken right now. And I'm actually not the only one who feels this way. Tim Berners-Lee himself is very concerned about the state of the web right now, especially with respect to the fact that users don't own their own data, the fact that advertising has become quite abusive, actually. I don't think that's an overstatement. So I'm going to try to make the case to you that the web is broken because of one architectural choice and that we can actually fix it. So I think HTTP ruined everything. More specifically, servers ruined everything. Let me explain. The web uses HTTP for getting documents from one computer to another. But HTTP is not well suited for connecting directly to other browsers or like other users. The way we host websites and the way we publish websites is by setting up a server, putting our website on there, and then pointing people to that specific server so they can retrieve the document. And what this means about publishing on the web is that you have to know how to run a server. But the truth of the matter is that 99% of the people on this planet are never, ever going to do that. It requires expertise, money, and it's just not fun. I mean, I know how to run servers, but I don't like doing it. I don't want to do it. So the web may, in theory, be permissionless, and it may be open to anyone publishing on it, but the fact of the matter is that is not how it works. Instead, most people publish through platforms like Facebook or Instagram or YouTube. And worse yet, not only do we publish through those services, but like they have all of our data, they decide how applications are built, and just really everything happens through these platforms. So if I'm going to make the case to you that the web is broken, I think I have to also convince you that there's something wrong with the centralized web, because the centralized web and the way the web works right now, it is working, right? Commerce is being done, people are making art on the web, and it's fast, it's free, it's reliable. So, okay, what's wrong with it? I can't just say that I don't like Facebook, although that is true. And I think there are actually some tangible things that we lose out on as a society and as users because the web is centralized. First of all, we have no meaningful privacy. So if I were to ask any of you in this room to send me a PDF document directly, no third-party servers allowed, how would you do it? I mean, maybe some people in this room like have ideas because you're into the peer-to-peer web, you know about DAT, you know about BitTorrent or whatever. But if you ask the average person, I think they would say Dropbox, a Google Drive, something that requires adding a third party to what should be a two-party transaction. Now, a lot of people will say, okay, I'm a good person, I have nothing to hide. But I think even a cursory glance at the arc of history should tell you that even the most morally upright citizen should care about communication privacy. Second, we get locked into walled gardens. So your data lives on the platform's servers. You don't own it. And even if you decide, I don't really like Facebook anymore, I think I want to try out Twitter or Facebook. You're kind of discouraged to do that, right? Because you've worked really hard to develop a network there, your friends are there, your content is there. So even if Facebook is not the best option, you're disincentivized to exercise choice. And I just think this is really dangerous because it means that these platforms can push the limits of what they do and how they behave. And as users, we don't really have much leverage to convince them to behave correctly. And lastly, as users, we use these apps built by platforms every single day, but they're uncustomizable, and we have little influence over what features are prioritized or what they look like or just how they function. And unfortunately, I think Twitter is a shining example of this problem. So recently, Twitter launched a new character limit, so you can now use 280 characters. It's weird because no one was really asking for that. People were asking for better moderation tools, maybe a way to share block lists with friends, or maybe not being exposed to neo-Nazi content. Twitter doesn't seem to care about those things, and I think it's pretty obvious why. Twitter is a business, an ad revenue-driven business, and they're going to ultimately do what drives ad revenue. And I mean, that's nothing new. Like, we've known this about ad revenue on the web for a long time. And, you know, as users, we have some leverage. We have a little bit of leverage, which is that our eyeballs are what are valuable to them and their business. So if we leave the platform for a short period, like happened a month and a half ago, I think, we can maybe convince these platforms to prioritize the features and the policies that we want them to. But I'm actually pretty unconvinced that this is ever going to get us to where we need to go. Twitter made some statements after this boycott. You know, we're going to be more transparent. We're going to work really hard to make sure that we're implementing our policies fairly. I think it's a PR move, to be honest, and no matter what, they care about keeping users on their platform. So, the web is broken, and I hope you feel that way too at this point. But thankfully, I think we can fix it, because there was only one thing wrong, which was HTTP. And so I want to pose the question, what if we didn't need servers? Like, what if we could publish on the web independently, truly independently? And what if it became easy enough that a regular person who's not a programmer or a systems administrator could do it themselves? That's exactly the experiment we're doing in Beaker. So we actually think that this can be achieved by using peer-to-peer protocols like DAT, BitTorrent, IPFS, or Tahoe LAFS. There's all sorts of different peer-to-peer protocols, and they're exceptionally good at helping people connect directly to each other. If you imagine that this is an example of HTTP, where you have to make a request to one specific server to get a file, if you're looking at a peer-to-peer protocol, when you want to ask for a file, you kind of just call out to the network and say, hey, does anybody have this file? And if so, can a couple of you send me the chunks that compose that file? And as the network of peers grow for that specific file, there are going to be more people contributing resources and bandwidth to help send you that file. So a peer-to-peer network scales really well as demand scales. And this is actually one of the hard parts about publishing independently on the web with HTTP, is that, well, if you have a video on your website and it suddenly goes viral, you're going to have a hard time keeping that server online, just because you're not going to be able to stand up to the demand. So a peer-to-peer protocol scales really well. Let's talk about publishing with the peer-to-peer protocol. It's pretty simple. You have a website that's composed of HTML files and maybe some CSS, and you can share the URL for it, and people will be able to download it directly from your device. Or if you wanted to get really fancy because you know how to run servers, you could even set up a server to basically make sure that your content is always online, even if you shut your computer off. It gets even more interesting when you think about what happens with user data. So like, if you have a Facebook account, you have your name, your bio, your posts. Well, imagine if that were just on your computer too. And not only that, but the application that renders your data or your friend's feed. It gets really interesting because if you have the application code for Facebook or whatever the peer-to-peer alternative is, then you can just edit it and you can customize it. And you can, if you don't like that they're using Bootstrap or you don't like the padding on their buttons, you can just change it. And everybody can do that. And it's kind of like we'll all have our own MySpace feeds, but we can still talk to each other and still share data and interact with each other. So that's the vision of the peer-to-peer web. We think that the web is wonderful, and I don't think we should get rid of it or try to rebuild it from the ground up, but rather just replace the transport protocol that we're using and make it peer-to-peer. Thanks.
Any questions? Let's see. I saw like 20 hands go up. So let's start here.
Hi. So I do a lot of research on agency for people online and how platforms kind of deny all of that for us. So I didn't know much about peer-to-peer before coming here, and now I'm like, oh, this is like a great idea. But in regards to people like me and others in this room that can't code and don't have that power right now to do any type of their own encoding, there's like a big feeling kind of like of helplessness. Like you can't choose not to go on Facebook unless, I mean, you can, but like when you don't use it, there's elements of your social ecology that will drop off. So I was just curious with your company or you personally or any other people here, like how much does restoring agency to everyday people like play a role in your motivation?
Yeah, we think about that a lot. Right now, Beaker is still very new, but we're already thinking about what it's going to take for someone like my father, who is not very technical, to be able to jump onto a peer-to-peer social media site and be able to just feel like it's as easy as Facebook. And I think we can actually achieve that because it's just the web, right? Like Facebook and Twitter and Instagram became very usable because they have nearly boundless resources to build incredible apps. It might take a little while for a peer-to-peer equivalent to evolve, but I see no reason why that can't happen over time. You should not have to be a programmer to engage in this platform. And agency is at the heart of everything we're doing here. We want people to own their own data. We want people to decide what kind of content they see or they don't see. It's really about control, I think.
So to jump off that, where do you see something like Beaker and peer-to-peer sharing in terms of artists or other people owning their data, but then in terms of like copyright, are you getting that, how are you going to tell everybody, hey, by the way, you're making something, go send it to the Library of Congress, or go do this? How do you encourage people to protect themselves if you're going to say, hey, here's my data, and then I can send it to you, and then you're going to take it and you're going to make it customizable? How do we in a peer-to-peer network protect against somebody doing something unsavory with it? Facebook was built as like revenge. Like it does exactly what it was. So it does exactly what it's supposed to fucking do. Like it's a terrible, terrible website that was built on hate. And like you think about Twitter and all these things that it could have done and what it's not doing and how it's not protecting people. So how do you implement that in a peer-to-peer setting?
Well, if you want to talk about copyright, I think the discussion is actually quite similar to any copyright discussions on the web today, because you can save any image from the web right now. So that question it doesn't really change. But in terms of protecting people and protecting against unsavory behavior, I think the fact that you can take any website on the peer-to-peer web or any app and tweak it to work however you like. You can fork it and add a new feature or remove a different feature or block a specific person by just choosing not to connect to them. I think that's a much better story for giving people control over how they want to engage on the web. Much better than having Twitter or Facebook basically act as monarchies and make these decisions for us.
But what if I take this beautiful thing you've made and then I'm like, and they're all Nazis, and you know what I mean? And then that's what I'm putting out. So I have this large audience. I connect to all of these people because I've cultivated it, and that's what I mean. It's like, yeah, so I can take it and I can modify it, and then I can modify it all the way into the ground, and as soon as something that you've built is torn down in 1 second by someone who doesn't like you or doesn't like your message or anything like that.
Yeah, that will most certainly happen.
Yes.
So it's kind of like where...
Yeah, I think Paul's going to talk about this after me. He talks about how we're able to filter content on the peer-to-peer web. And I think that's a really powerful thing to wrap your head around with the peer-to-peer web, which is as users, will be so much more empowered to just ignore people. Like Twitter, you can block someone on Twitter or mute them, and somehow their content will still show up in your feed, even though it's not what you want to see, because you're not in control of deciding what kind of content is going to be put in front of your eyeballs. But yeah, nasty stuff is going to happen no matter what.
So then it's like, I guess I look at it that way, that you're advocating people living in a bubble and building into a bubble. So if you're blocking all of this content that's not coming in, how are you supposed to get anything different than what you're already seeing. So you've set all your filters to, you're not hearing the other side. You're not seeing, 4 degrees of separation from that idea that could bring change. You've got this kind of like hive mentality. How is that a good advocate for what we already don't like to see in the web in the way that it is?
Yeah, that's a good question. So on the peer-to-peer web, you have to explicitly say that you want to connect with someone. But there's ways around that. Like if you want to expand your bubble or expand your reach, you can look at like your friends and see who they're following and see who those people are following and do that infinity times. And I think that actually takes you very far. There are a couple existing peer-to-peer social media projects, and that's kind of how they populate your feed when you first sign up, is by just looking at friends of friends of friends. And I think that actually takes you pretty far. We have to figure out how to strike a balance between finding reach, and making sure that users are able to have agency over what they see or do not see.
Yeah, I also think like when you said filter, that this past year specifically, there's been such like an amount of discourse surrounding filter bubble, or whatever like filter bubble stands for. And there's something that and this plays back into the scale side of things perhaps as well, where maybe there is just like and this is just like one possibility that comes to mind, but maybe there is something to be said about like a scale of operation where it stops being something which is like a group of your friends, and now you're exposed to the entire planet or something like this. And that's kind of like intrinsic to the scale. And also how filter bubble kind of finds itself as a result of like algorithmic recommendation systems, and it becomes like a very self-reinforcing type of like, you like this, you like this, you like this, you like this. Whereas you probably have like and your group of friends is a diverse group of people who are, you're interacting in your environment day to day. Like you go to the grocery store, and the person who's checking you out, like maybe there's like a huge generational gap in all these other things, and that's like exposing you to something that needs to be present in your life period, right? And so the difference between like algorithmic recommendation systems that are operating on a global scale versus like a more like it's something that's closer to you, I think, and that's what a lot of these things are lacking, is that closeness, maybe. Yeah.
Or do you want to try?
For the streamers.
I had 2 questions. First one was, how does a peer-to-peer network solve the problem you posed about sending a PDF from just me to just you?
Well, peer-to-peer networks are very good at getting content from one client to another client. So if you were going to do it in Beaker, you could just upload a PDF to like what we call a website inside of Beaker, and then send me the link to that website, and I could download it.
But doesn't peer-to-peer networks, does that essentially mean that it's going to be sent through the entire network, all the peers are going to have access?
No. So there's a discovery network, and Max and some other folks here are probably better to ask these sorts of questions too, but no, the only person who will be able to download that file is me, or whoever else you share the URL with.
Yeah.
Who enforces the rules about that?
That's actually built into the protocol. So if I believe that on the DAP protocol, the actual traffic is encrypted with the URL. And so in order to like discover the traffic and decrypt the content, you need to know the URL, which is effectively unguessable. If it is guessable, then all of modern banking and the web is going to be broken.
Right, but that same cryptography can be used with a centralized server for the same purpose.
What's that?
You could but that same encryption can be used with the centralized server in the same way, and it's still just, I don't understand the difference.
Oh, well, they don't do that because they want to look at your data because it's useful.
With like, you gave the examples of like file sharing services like Dropbox or whatever. If I encrypt the file and give it to you, the link, how is that different than what your? I understand.
Oh, right. Yeah.
How is the centralized
So
server person different?
you're suggesting
effectively different for the end user.
Right. So you're suggesting that you could encrypt the file first, put it on Google Drive or Dropbox, and then that Google Drive wouldn't be able to look at it. And that's true. But in terms of convenience, that's 2 extra added steps, because you have to encrypt it and then your recipient has to decrypt it. And your recipient and you have to exchange keys ahead of time. So using a peer-to-peer protocol is just a much more convenient way to do that direct sharing.
Okay, and then I had one other question.
Real quick, because how this relates to design and things like that, like the tools that you make have affordances, and even though something is possible, it doesn't mean that people are going to use it a certain way. And so the way that you, for instance, like the example with the encryption in Dropbox, I feel like if you have an awareness of how a service like Dropbox has centralized access to your files, then that's absolutely something that you want to be doing. But given the affordance of the tooling, that's not necessarily something that they're designing for. And that's a really important thing with these types of projects, is to how do you communicate affordance through the design in a way, and how do you abstract things behind there, because you don't necessarily know. You could think that perhaps Dropbox is doing something like this, but actually they do have access to the files on the server, and that's like a specific example, but yeah, you answered that a lot better than I did. Maybe we have time for one more question. Yeah.
Not really a question, just will you share your slides?
Yeah, I can share them.
Cool.
We will be sharing slides.
Awesome. Thank you.
I'm curious what your thoughts are. I'm a backend engineer, so I'm curious what your thoughts are on how to do backend compute on a network like this. Because I know this is all documents, right? But at some point you're going to want to do some type of data processing. Like Facebook has tons of APIs that in the backend do tons of data processing, and I'm curious what your thoughts are there.
So a peer-to-peer network is really good at getting documents from computer to computer, but it's not good at doing anything that involves aggregation. So like, if you want to search the whole network, you're still going to need a crawler, just like Google is a web crawler and provides a sort of global view of the web. And I think you're definitely going to need services to do that sort of large-scale compute, and that's totally okay. There's nothing wrong with that. It doesn't harm the integrity of what we're trying to achieve here, because what we're trying to achieve rests on moving data and user control from platforms and servers to the user's device. Yeah.
Oh, yes.
No, I was just gonna suggest that we wrap up and move on to Paul, since we have to catch a flight.
Cool. Oh yeah. Good point. Thanks so much. I mean, that was amazing. So this time, if you need to use the restroom or something, feel free to do that. But otherwise, I think we'll just continue through to Paul real quick, and then we'll take like a nice little break between Paul and Max. So just 2 momento.